Coach Hyde, going over speed and motion. So we looked the other day at motion graphs, um, things that kind of look like this, right? So trying to understand what this is, specifically solving for velocity and then solving for acceleration. So looking at this first, so velocity, first off, let's define it as how fast something is moving. Well, this is just speed. So velocity is just speed, but it's also a little more specific than speed. It is the direction of travel. So if you look down here and it says which one of these is a speed, which one of these is velocity. So looking at it, right, this has, all of them have a numerical value, right? And then look at these. So this is our unit for speed, right? So meters per second, miles an hour, kilometers a second, kilometers an hour, whatever. These are our units for speed, a distance and a time. What is different about this is these, right? These are directions, okay? Directions. So if it has a direction, it's a velocity. If it does not have a direction, it's just a speed, right? So all velocity is just speed and direction. All right, moving on. So our formula for speed, you can find it, you can see it right there at the top left of our formula sheet. So if you forget it, it's right there for you. Don't worry. It has both versions. Now in the right here, it'll say displacement. Here I have distance. Displacement and distance are different, as we discovered, but for our purposes, if you're given a distance and not a displacement, just use the distance. All right, so we got a couple practice problems here. So let me grab my marker here. It says Walker, Texas Ranger can straight kick a 2-meter tall dude right in the mouth in a tenth of a second. What is the velocity of this straight kick? All right, so our formula is V equals D over T. All right, so we have a spot here, and here. So we need to plug in some numbers into these spots. So to do that, we read through. So right here, it says, what is the velocity? We're looking for the velocity, so we plug in the V for the velocity. Next, we look at this. 2 meters is a distance. And then 1/10, which is 0.1, is our time. So then you just divide this. 2 divided by 0.1, right? It's like how many 10-cent pieces, how many dime pieces are in $2, right? It should be 20. So our answer is 20. These units do not cancel. 20 meters divided by seconds. And down here, talking about Dr. Quinn, Medicine Woman, two of my favorite shows. So 1867, Dr. Quinn, Medicine Woman, pure Litchfield, Colorado Springs. So we got 8 kilometers away. That's a distance. We have this. This is going to be our speed, right? And we want to know how long. So we want to know time. So in this case, we're looking for time. So we're going to set it up. 4.83. And our distance is 8 kilometers over time. I won't run out of space here. All right, so up next, we're going to multiply by t, right? Multiply by t. So that did not really satisfy what we got. I'm just going to move this equation over here now. So now we got t times 4.83 kilometers an hour equals 8. So now we're going to do the same thing again. We're going to divide by 4.83. Divide by 4.83. I don't remember what this is exactly. Oh, we got kilometers an hour. Kilometers cancel. I think it's from my 1.6 hours. All right, so now moving into the graphs. I know this was a really quick rundown, kind of that second one here, trying to hurry to get this done before I got to go on bus duty, you know. But going into the distance versus time graph, right? So we look at this graph. We got distance is on our y-axis and time is down here on the x. So every time we go up, we're going up 1 kilometer based on this, right? So our slope, so if we go up 1 kilometer over 1 hour, up 1 over 1, up 1 over 1. it's going to be 1 kilometer per hour. If it's not moving, right, there's no change up or down in our direction. So this is going to give us 0. And then here we have slope again. So this is going to give us our velocity. All right, so just a couple of examples of this real quick. So looking at interval A here, okay, this interval here, to solve for this, right, we need v equals distance over time. So you want to find two spots. So there's a spot here, and a spot here. And this is where the line hits on these cross ties, right? See how it crosses right here? That's what we're looking for, those points. You can use any 2 points. All right, I'll just use the first one. First two. So these 2 points here. So when I go to this point, I got to go up 1, up 2 kilometers. So my distance is 2 kilometers. And then I went over one of my time periods during this. And this ends up being half an hour. So you see here, I would have to go over 2 spaces to get to 1 whole hour, but we only went over 1. So my time, I don't know where my little doohickey is 0.5 hours. This is going to give us 4 kilometers an hour. All right. At interval B, there is no change in distance. All right, it's a flat line. If there's no change in distance, velocity is just 0. All right, interval C, again, we're climbing up 1, 2, and then over 1. Right, just like over here. So, where's my little thing? There it is. So, we go up 2 kilometers over 0.5 hours equals 4 kilometers an hour. At D, okay, D, we're flatlined again, so our distance is not changing, so we know that the velocity is 0. Now here on E, let's find our points. There's one there, 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 and there. You can use any 2 of these, right? So let's say this one, right, from here to here. I move down 1, 2. Okay, if I move from 6 down to 4, this is going to be 2, negative 2, because I'm going down. And then I move over 1. Moving over 1 down here takes me to 4 to 4.5, 0.5. This is going to give me negative 4. Now, the negative number, you cannot have a negative speed, but you can have a negative velocity. All the negative means it's not a number less than 0 like you're typically used to, but it just tells us it goes in the opposite direction. We went up here, we're going down here, or we went left here, now we're going right, or we went forwards, now we're going backwards. All right, moving on next. Excuse me. Acceleration. All right, acceleration. There are 3 possibilities for acceleration. Acceleration is just a change in velocity. So if velocity is speed and direction, if you change either one of those, then you're accelerating. So you can change velocity, you can change the speed by increasing speed or decreasing speed. That's way. Or you can change direction. Or you can do both of them at the same time. Here's where our formula is. All right, so looking at this real quick, we see we don't have distance over here. So this is a little bit different graph. It looks very similar, but it's a little bit different because we're measuring velocity as we go up. And the biggest difference is, whereas before, our flat line, all right, so like this here, our flat line, right, on the distance and time graph means there was no motion. This means there's no acceleration, but it's still moving. It's like driving down the road in your car 50, 60 mile an hour with the cruise control on, not increasing or decreasing or turning or any of that kind of stuff. But we're going to do this very similar to the way we did before, almost exactly the same. If you just find the slope, then you will find your acceleration. So let's do a couple of examples of this. So from interval A to B, we're trying to find acceleration. We'll get the green out. I think it shows up a little better. So we need to find the points, just like we did before. So we got a point here, here, and here. So we got to use 2 of those points, right? So I'll use these 2, from this one to this one. So our acceleration formula is A equals final velocity minus initial velocity over time. So my initial velocity is here because I'm starting here and I'm moving up to my final spot here. So that's going to go in the top. So acceleration equals final velocity, which is going to be 8 meters per second. Initial velocity, which is 4. All right, and then I need the time it took to get there. So I started at 2. I ended at 4. So that's going to be 2 seconds. All right, 8 minus 4 is 4. 4 divided by 2 is 2 meters per second squared, or meters per second per second. All right, let's do one more example of that. Just C to D here. So again, I got a point here, and I got a point here. There's no other points I use, so this makes it easy. I got to choose. All right, so I'm starting here. So this is my VI. I'm ending here. This is my VF. So I'll do it over here. So my VF, or VF is down here. VF is 3. My VI is 10. The time it took to get there now. So just go down. So we got 10 and 12. So from 10 to 12 is 2 seconds. This is going to be 7 divided by 2. 3, well, negative 7. 3 minus 10 is negative 7. So it's going to be negative 3.5 meters per second per second. This means that I'm slowing down. All right, so that's an example of each. Let me know if you need more. Let me know if this helps. Let me know if this don't help. Catch y'all on the next one.